What is the normality of a solution containing 50 grams of HCl in 1.5 liters of solution? So I'm going to do this two ways. The first way, I'll do it the long way. Normality is the number of equivalent weights divided by the volume in liters. So the equivalent weight then is how much of HCl do you need to produce 1 mole of H's. And since there's just 1 H for every 1 HCl, it'll be the same. So 1 mole of HCl will produce 1 mole of H plus ions. And so I can work out that by finding the molar mass of HCl, which is 36.46 grams per mole. And again, since I know that 1 mole of HCl will produce 1 mole of H2SO4, then I know the equivalent weight of H2SO4 is the same as its molar mass. Had this been, say, H2SO4, then I would know that the equivalent weight of H2SO4 is half of what the molar mass is. So to find the equivalent weight, you may want to write this down, is take the molar mass of your whole chemical and divide it by the number of H's. So in this case, there's just the 1 H, so the molar mass will equal the equivalent weight here. If I divide it by 1, I get 36.46 grams. And so the question then, or that I need for the equation here, is how many equivalent weights then is 50 grams. And so we can find that by taking the total mass given here, divided by what one equivalent weight is, and we get 1.37. Now all I need to do is plug that into the formula and divide by the volume, which was given in liters, of course, and I get 0.914 normals. So that's all well and good. That's the right answer, and we're done. However, I'm going to show you another way of doing this, which you might find easier since you're more familiar with all these things. You don't have to worry about the concept of equivalent weight or anything like that. The other way of finding normality is to take the molarity, which you should be very familiar with by this point, and times it by the number of hydrogens. Now, this is only true for acids. That I should point that out. Because acids were interested in the H's, then that's what we're multiplying by, the number of those. You could be interested, say, in the amount of sodium in a solution, and then you would simply replace the H here in this formula with the sodiums in your solution. So whatever it is that you're interested in, for whatever reasons, you can replace that ion with the H. Since we're talking about acids in this module, we'll worry only about the H's. So, you know you have 50 grams of HCl and you have 1.5 liters, so you can figure out your number of moles of HCl. This shouldn't be new to you. By taking the 50 grams and dividing it by the molar mass of HCl, and you get 1.37 moles. Now to find the molarity, you'll take your number of moles and divide it by the given volume, and that gives us 0.914 moles per liter. And if we plug that into the formula which I just gave you above, molarity times number of hydrogens, we get 0.914 times 1, since there's just the one hydrogen in HCl. And so the normality then is 0.914 normals, same as we got doing it the other way. You may wonder then, well, what's the difference? There actually is no difference. This way might be easier, though, when you have to worry about, like, say, H3PO4 or something like that. It may be easier for you to find the molarity first and then just multiply it by the number of hydrogens, as opposed to worrying about the concept of equivalent weight. But either way, it doesn't matter. And also note that when there's just the one of your ion of interest in a formula, like in this HCl, there's just the one H, then your normality and your molarity will be the same number, which is what we got in this case.